everyone. Today we're going to go through IXL Assignment 5RX, all about triangle inequality. First, let's refresh our memory on what the triangle inequality theorem is. So the triangle inequality theorem tells us that in order for a shape to actually form a triangle, the sum of the lengths of any two sides is greater than the length of a third side. All right, let's break that definition down with our diagram here. So the sum, meaning the answer to addition problem, tells us that if we add any two sides, let's say we add side A and side B together. Those together, when we add them up, it has to be greater than the length of side C. Now, because our definition says this is true for the lengths of any two sides, we have to figure out all the possibilities. We have to test and make sure this is true in all the different scenarios. So now, if we were to add the lengths of side A and side C, those two would have to be greater than side B. And last but not least, if we were to add our final combination of sides B and C, those two together would have to add up to be greater than the length of side A. Let's look at an actual example worked out. So here, if we wanted to know whether or not the side lengths 5 centimeters, 8 centimeters, and 12 centimeters could actually form a triangle, we would need to test out all of our possible combinations. One thing that you can do, which is what I did here, is I labeled my sides A, B, and C. Then I can just follow and look at our notes here and make sure that I don't miss any sides. So first off, if we add side A and B, that would be 5 and 8. Well, 5 plus 8 is 13. That is greater than 11. That one checks out. Or I'm sorry, greater than 12. I got a typo there. If we look at our second combination, let's add side A and C together. So 5 plus 12 needs to be greater than 8. 5 plus 12 is 17. That is greater than 8. That checks out. But we can't stop there. We got to do our final set. Now, if we add sides B and C together, 8 plus 12 has to be greater than 5. Well, 8 plus 12 is 20, so it checks out. Because all of these works, all of these different sets work, that tells us that these three sides would form a triangle because it meets my requirements. Now, what would happen if we had a set that didn't work? Well, let's look at this one. In this case, we want to know if 5 centimeters, 6 centimeters, and 11 can form a triangle. So once again, if you want to keep yourself organized, you can just label these sides, just go A, B, C, and then right up here, follow these three different sets. So first add sides A and B together. Well, 5 plus 6 would be 11. Is 11 greater than 11? No. And if we look closely, our inequality sign is just a greater than. It's not greater than or equal to. Therefore, it is false. Once you get one false statement, once you get two sides that are not greater than the third, you can stop, because that means those three sides will not form a triangle. It doesn't matter if the other two combos work. If one combination doesn't work, nixed out. If you were to try to make that fit into a triangle, two of the sides wouldn't match up. There'd be a gap between them. All right, let's head on over to IXL and do some more practice with this. Okay, here we are on IXL. We are on our triangle inequality assignment. First question, can the sides of a triangle have the lengths 1, 6, and 6? All right, we need to test these out. So remember, we got to test it out 3 times to make sure it works for all 3 scenarios. First, let's just add our first 2 together. So 1 plus 6 has to be greater than 6. Well, 1 plus 6 is 7. That one checks out. Now, let's do the second and third one. So 6 and 6. 6 plus 6 has to be greater than the other one, which is 1. 6 plus 6 is 12. 12 is greater than 1. That also checks out. And last but not least, let's add our first one and our last one. So 1 plus 6 has to be greater than 6. All right, that worked for all three, which means this set of side lengths would in fact create a triangle. So our answer is yes. Let's check this one out. Can the sides of a triangle have the lengths of 2, 9, and 10? All right, once again, we got to add up all of our sets. So the side lengths of any two have to be greater than the third. Let's just add our first two together. So 2 plus 9 has to be greater than 10. 2 plus 9 is 11. That is greater than 10. It works. Let's now check out the last two. So 9 and 10. 9 plus 10 has to be greater than my third one, which is 2. 9 plus 10 is 19. That is greater than 2. We're good to go. And then for our last pair, because we got to guarantee that it works, is add the first and last one. So 2 plus 10 has to be greater than 9. 12 is greater than 9. All right, it checks all the boxes off, meets our requirements. So yes, sirree, those lengths would create a triangle. All right, let's bump it up a notch here. Can the sides of a triangle have lengths 3, 3, and 14? Let's find out. Let's add the first two together. Is 3 plus 3 greater than 14? 3 plus 3 is 6. Is that greater than 14? No, it's not. Once you get a false statement, you can stop, because if even one combination doesn't work, then it will not form a triangle. So nope, that wouldn't work. All right, let's bump it up another notch. Can the sides of a triangle have lengths 5, 4, and 9? All right, add the first two up. So is 5 plus 4 greater than 9? 5, 6, 7, 8, 9. 9 is greater than 9. Does that work? No, 9 is equal to 9. And for the triangle inequality theorem to work, it has to be greater than. So once again, that doesn't work for us. All right, let's try one final problem together. Can the sides of a triangle have lengths 5.4, 13.5, and 11.6? Even though we have decimals, the process of this is the same. You will just need to make sure you add decimals. This is a great review. Make sure you're doing this without a calculator so you can practice your adding decimal skills. So I'm going to format this a little bit differently. I'm going to stack my numbers when I do my addition. All right, I need to add these two and see if it's greater than 11.6. So 13.5 and 5.4. So 5, 6, 7, 8, 9. Bring your decimal down. 5 plus 3 is 8. Bring down the 1. Is that greater than 11.6? Yes, it is. Let's try our next set. So 13 and 5/10 and 11 and 6/10. When you're adding, it doesn't matter which number you put first as long as you line up your decimals. So 6 plus 5 would be 11. Make sure to carry that 1. 3 plus 1 is 4, plus another 1 is 5. Bring that decimal straight down. So is that greater than our third side of 5 4/10? Yes, sirree. Let's try our final set. So we'll add our first and our last together. So 11 and 6/10 plus 5 and 4/10. 6 plus 4 is 10. Carry the 1. Make sure you bring your decimal straight down. Is that greater than 13 and 5/10? It is. So even though we had decimals, we can still add. We just got to make sure you probably have some paper in front of you, a little bit harder to add that in your head. but yes, it met our requirements. It is in fact a triangle. Okay, it is your guys' turn to try it. Just remember to make sure that you do all your combinations. You can either label them A, B, and C, or you can do like I did, just make sure you do that pattern of the first two, the last two, and then your ends. Whatever works for you, as long as you try all three combinations. As always, if you have any questions, make sure to reach out to your teacher and we'll be happy to help. Good luck.